Hi everyone, welcome back to day 2 of parallel lines cut by a transversal. What we're going to do today is we're going to use those angle relationships that we talked about in the previous lesson and figure out how to find angle measures when we're given algebraic expressions for our angles. So this is really important that you know when the angles are congruent versus when the angles are supplementary, because there's only 2 ways to set up an equation for these problems, but you have to know which is which. Okay, so that's really going to be the focus of today, along with some more notation that we're going to really focus on. Okay, so in example 1, it says lines A and B are parallel, and line M is a transversal. If the measure of angle 1 is 67 degrees, and the measure of angle 7 is 2x plus 5 degrees, what is the value of x? Okay, so a lot going on there. Again, they have to tell you A and B are parallel, otherwise the relationships that we've learned don't work. And then they're just telling you that line M is in fact a transversal, meaning it's intersecting your 2 parallel lines. So they give us the measure of angle 1. I'm going to label that right away in my picture here, so I know that that's 67 degrees. And then they tell me an expression for angle 7. They say that that's 2x plus 5 degrees. And so what they're asking us is, what is the value of x? And then what name would we use to describe that pair of angles? So why don't we talk about that first. Looking at angles 1 and 7, we can see that those are both acute angles. And in this type of picture, this type of diagram, when the angles are both acute, that means that they are congruent. And more specifically, if you look at the placement of those angles, 1 and 7 are both on alternate sides of that transversal, and they are outside the parallel lines. So these are called alternate exterior angles. Somebody's phone is ringing in my room. Sorry, can't answer. Okay, so alternate exterior angles, again, means that they are congruent. And so for your equation, we have to show that they're congruent, that they're equal. So we're going to say angle 1, which was 67 degrees, is equal to angle 7, which is 2x plus 5 degrees. And so that's it. That's our equation that we have to solve. Okay, so I'm going to subtract 5. And then I'm going to divide by 2, and I'm going to get that x is 31. Okay, now they don't ask us to go back and figure out the measure of each angle, but if we had to do that, we would have taken what we got for x, plugged it back into the expression for angle 7, and then we would have ensured that, both are equal to 67. So we could do that really quick. 2 times 31 is 62, 62 plus 5 is 67. But we can stop there. Okay, so example 2. In the diagram below, lines A and B are parallel and line T is a transversal. If the measure of angle 2 is 112 degrees and the measure of angle 5 is 9x plus 5 degrees, what is the value of x? Okay, so again, let's label what we know. So angle 2 is 112 degrees. And angle 5 is 9x plus 5. Okay, so looking at those 2 angles, let's talk about the relationship first. Angle 2 obviously is obtuse because they tell us it's 112 degrees. And just by looking at angle 5, we can see that it's acute. So right away, we know that these angles are not congruent. And the only name we can give them in this type of diagram, if they're not the same, is that they're supplementary. Okay, so we know that supplementary angles, when they're added together, equal 180 degrees. And so our equation has to show exactly that. So I'm going to start with my 112 degree angle, and I'm going to add it to its supplement, 9x plus 5, and that has to equal 180. Okay, so at this point we're ready to combine like terms. 112 plus 5 is 117. I'm going to subtract 117, which which gives me 63. Divide by 9, and we're getting that x is equal to 7. Okay, great. Number 3. Transversal EF intersects parallel lines AB and CD at G and H. The measure of angle BGH is equal to 3x minus 20 degrees, and the measure of angle GHC is equal to 2x plus 10 degrees. Find the indicated angle measures. So what we're going to do is we're going to first label what we have for each of these angles. So BGH, if I follow my letters there, BGH is this angle. That's what they're referring to. And so that is 3x minus 20. Okay, the other angle, GHC is this angle, and they're telling me that that is 2x plus 10. Okay, so what do we know about those two angles? Well, we can clearly see they're both acute, which means they are congruent. And so setting up our equation should show exactly that. Now we have a bunch of angles to figure out. We'll worry about that after. Let's figure out what x is first. That's going to be what we need to do. So again, because they're equal, I'm going to say in my equation that they're equal. Okay, so to solve something like this, we need to get our variables to one side. So I'm going to start by subtracting 2x. And then I'm going to add 20. And so I get that x is 30. So what I would suggest doing from here, because we're going to have to find all of these angles, is let's go through and let's plug in x is 30 into both of those expressions. So I'm going to start with 3x minus 20. So if I plug in 30 for x, I get that that angle is 70 degrees. And I should get the same thing for my 2x plus 10 because we said that they were congruent. So 60 plus 10 is indeed 70. So that's good news. We know that we did something right there. So what I'm going to do is I'm going to actually erase this, and I'm going to plug in, now that I know that is 70 degrees, so is that. And why don't we, for the fun of it, before we go through and figure out what angles they want here, let's label the rest of the angles in our picture. Okay, so automatically this angle up here is 70 degrees because it's vertical and because it's acute. And for the same reason, this angle down here is 70 degrees. And so all of the acute angles in that diagram are all 70 degrees. So now let's figure out what all the obtuse angles would be. So remember, an acute plus an obtuse in this type of diagram has to equal 180 degrees, which means all of these obtuse angles have to be 110, because 110 plus 70 is 180. All right, so going back over to our list of things here, angle BGH. So oops, I wrote over G. Where's G? Oh, right there. BGH is this angle. That's actually the one that we had originally. So that's 70 degrees. DHF. DHF is this angle. That's the other one that we know is acute. That's 70 degrees. CHF. CHF is this angle here. So we labeled that as 110 degrees. And EGB. EGB is this angle here, which is 110 degrees. Okay, awesome. Turn the page, a couple more here. All right, example 4. In the accompanying diagram, parallel lines AB and CD are intersected by transversal EF at G and H respectively. If the measure of angle AGH equals 4x plus 30 degrees, and the measure of angle GHD equals 7x minus 9 degrees, what is the value of x? Okay, So one thing that's different about this is they tell you the points at which the transversal intersects the parallel lines. Okay, so when they say at G and H, they're just saying that's where that transversal intersects those two lines. Not a huge deal. It's actually just going to help us when we go to label our angles. Okay, so AGH, if you follow your letters there, AGH is this angle. That's what they're talking about. So I'm going to label that 4x plus 30. And then GHD, that's this one here, and that is 7x minus 9. All right, so let's talk relationship first. Those two angles are acute. They are on opposite sides of the transversal, and they are inside the parallel lines, so we call those alternate interior angles. What do we know about them? We know they are congruent. So when I'm setting up my equation, I need to show 4x plus 30 equals 7x minus 9. And then we can go ahead and solve that. I'm going to subtract 4x to get my variables to one side. And then I'm going to add 9. And then I'm going to divide by 3. And I'm going to get that x is equal to 13. Okay, example 5. In the accompanying diagram, parallel lines AB and CD intersect transversal GH at points E and F respectively. If the measure of angle AEG is 4x minus 15 degrees, and the measure of angle CFE is 2x plus 7 degrees, find the value of x. Okay, so again, we have these two parallel lines. They're telling us the transversal intersects them at points E and F. And we know the measure of angle AEG, so AEG would be right here, is 4x minus 15. And CFE is this angle here, and that's 2x plus 7. Okay, so let's talk about the relationship first. They are both in the same part of their little group of 4, okay, top left there, and so those would be called corresponding angles. And we know that corresponding angles are congruent. We can also see that they're congruent because they're both acute. So again, our equation would show that 4x minus 15 equals 2x plus 7. All right, so let's get our variables to one side, subtract 2x. We're going to add 15. And we're going to divide by 2. And we get that x is equal to 11. All right, last example, example 6. In the accompanying diagram, parallel lines AB and CD are intersected by transversal EF at points G and H respectively. If the measure of angle CHG is x plus 20 degrees and the measure of angle DHG is 3x degrees, find the value of x. All right, so let's find out where these angles are. CHG is right here. That's x plus 20. DHG right here. That's 3x. All right, so what relationship would we give these? Well, the first one is acute. The second one is obtuse, and so we know they're not congruent. And so our only choice when they're not congruent is that they are supplementary. They're going to add to 180 degrees. So in our equation, we need to show just that. The first angle plus the second one is going to add up to be 180. All right, so we'll combine like terms. We will subtract 20. And we'll divide by 4. until x is equal to 40. Nice job, guys.